Good afternoon. Welcome to today's webinar, Go Green or Go Home. Today's webinar is going to be presented by Noah Bethel of PDMA. I'm Doug Wagen with UE Systems. For those of you who have logged on today, we certainly appreciate you taking an hour out of your day to listen to what I think is a real appropriate topic at this stage of the game, which is going to be Noah discussing, the ramifications of going green and how that affects overall plant reliability and how it affects energy conservation and energy savings. One of the things that as a company, UE Systems has tried to do over the past year is bring extra value to our customers. And we're trying to do that by an assortment of different informational webinars of various topics that all sort of tie into a common theme, and that's if you've got a safe, energy efficient, reliable plant, it's going to add directly to your bottom line. So without further ado, I'm going to go ahead and kick it off here just with a couple of quick comments about who we are, what we do. UE Systems has been around for quite a while, over 35 years in the ultrasound field, a very large global footprint. We've got offices all over the U.S., offices for international support in Mexico, Canada, South America, Europe, Asia, and India. Just a little map there with our global footprint on it. You can see we're located in beautiful Elmsford, New York, about 20 miles north of New York City. We have the green stars represent our regional offices spread throughout the globe, and then our blue stars represent our regional support offices to be able to offer technical support on our equipment. As an equipment supplier, one of our firm beliefs at UE Systems is that the use of the technology is great, but it's not enough. You have to learn how to integrate the different technologies into your overall maintenance and reliability program to make those programs effective, the very best that they can be. So without further ado, I'm going to go ahead and welcome Noah here. I'm going to turn the screen over to him. And Noah, why don't you go ahead and take the screen back from us, and we'll get things going here this afternoon. Thanks, Noah. I really appreciate you being here. And sharing some of your insights with us.
Not a problem. It's great to be here. Hello from sunny Tampa, Florida. It's not always as sunny as it. How's that look, Doug? Is that looking good? All right. So again, hello from sunny Tampa, Florida. It's good to be here. The topic of discussion here is one of interest, and it's got kind of a little bit of an interesting spin on it, in that it affects all of us. And green means different things to different people. Like I said, when I give this presentation on stage, I like to bring out a dollar bill and say, hey, this is green to everybody, right? We can all relate to that, and that's very good. And so that being said, green means different things to different people, and some people look at green as more of the environmental impact and all that kind of stuff, and that's all very good, and it's good to be part of that effort. For today, it's going to focus on one facility's pressure, pressure on themselves, pressure from corporate to basically perform and perform at a high level. Now, the company we're going to be talking about is Austin Energy. We'll give you a little bit of a little background on that facility, what they do, how much power they make, how they make it. We're going to go from there into a topic that is critical to all of us, and that's reliability. Reliability is as much green as energy efficiency, and I can't say that enough, and I think we'll prove that again and again, certainly through this presentation. And you can hear Doug talk about the same thing, which is the reliability effort through the multiple technologies is probably the biggest return on investment that someone can make it be efficient and to go as green as possible, make as much product with as little energy as they possibly can. And then we're going to wrap it up with a phrase that's been heard before, which is cradle to grave reliability. And we're going to talk about electric motors specifically. How do we follow them from cradle to grave and ensure the reliability of those motors? A little bit about myself, what qualifies me to present this information. Like I said, I work for PDMA Corporation. We manufacture test equipment, much like Doug in the UE group, and we're focused a lot on more the electrical side of motors. But I cut my teeth in the U.S. Navy on submarines and working with low voltage, high voltage DC, a variety of other types of motors and distribution systems and qualified myself through multiple technologies and reliability, including ultrasonics and current signature, power analysis, motor testing, the whole bit. So I've been out there, got my hands dirty in a little bit, and now I focus primarily on manufacturing technology for the motor reliability and energy efficiency side of things. So hopefully it gives me something to talk about today anyway. First on Austin Energy. Austin Energy, located in Texas, obviously, is a 2,600 megawatt facility. They produce power for mainly regional area there, but of course they're connected to the grid like most utilities, and they're going to supply power to part of the country, in fact. They operate off 5 primary utility plants, being nuclear, natural gas, coal, and of course wind generation. So they do touch a lot of green energy sources, and for that, you know, it puts them in a good perspective in terms of, you know, trying to establish themselves as a green organization, and their investment in wind generation, of course, being the front in terms of going green. But nonetheless, a well-respected company. And speaking of well-respected, it's worth focusing a little bit on their accomplishments. They were the first organization, first utility to go into the green building program in the country. And that's basically their partnership with society, with the you know, customers to assist them in building green facilities and really focusing on energy efficiency. And then that gets certain awards. In fact, they did receive the award for the National Association of Homebuilders as the U.S. Green Building Council, which is no small award. And that's, I think, one of the you know, in terms of the really the first in the nation, and that's, like I said, it's a world-recognized award, so it's a pretty big deal. And of course, they are a charter member of the U.S. Green Building Council. So all that being said, I think it certainly sets them apart in terms of utilities and their effort to go green. So now, that being said, this is where it gets interesting. Imagine, let me go back for a second, just real quick, and focus on these awards again. Imagine if you're a company that prides itself in the effort to go green. You pride yourself in the ability to establish the construction of various facilities and to supply them energy, and knowing that in the whole time you're sort of preaching the energy efficiency approach. And imagine if you were to find out that your own facilities were not necessarily following the guidelines that you establish in the green building program. And that's kind of what they were starting to experience, is that through their own facilities that they were maybe not necessarily talking, they were talking the talk in energy efficiency, they were talking the talk in going green, but they weren't necessarily walking the walk, and that became a big deal. And it became such a big deal at one point, they actually contacted all the facilities within their organization, and they said, hey, we cannot live this way. A good analogy might be if you're a preacher preaching morality to the patrons or to the parishioners, and you have to go to jail the next morning to pick up your kid. It kind of doesn't set very well, right? So in this situation, you got a facility who's preaching big time going green, and yet their own facilities are coming up short. So they put out pretty much a very strong agenda, which is either to each of the facilities and the 5 that they were really focusing on, that they either will go green, and of all likelihood, one of them might go home. And what they meant by that was, you know, the least performing facilities have a high likelihood of being shut down and mothballed, basically. So as an employee, as an investor, as a person that's involved in a facility like this, you're wondering, wow, are we going to be the ones selected to go home? And that's not a good feeling for anybody. So there was a lot of stress, a lot of pressure created at the we're going to perform as a facility, or we're going to be the low-hanging fruit that are going to have our doors closed. So you can imagine this became an interesting conversation. The products that we create, we need to have less emissions into the environment. All that we need about that they can meet or exceed the minimum efficiency standards. Well, it becomes to say, hey, you will go energy efficient or you won't go at all. To just simply say, hey, we're going to replace motors with energy efficiency motors. That's going to save us thousands and thousands of dollars. And sometimes that is too easy to hear and see, but it doesn't necessarily show to be true when you actually look at the numbers. Now, speaking of truth, when it comes to energy efficiency motors, I think it's important to talk first about the misconceptions of energy efficiency motors, because certainly we're looking at a company who is immediately thinking we're going to be replacing a bunch of old motors with high efficiency motors, and what does that mean to them? Well, the number one most common misconception of an energy efficiency motor is that an oversized motor is less efficient. So these people are walking around their plants, they're saying, wow, look, this motor's running at 70%. Well, we could replace that with a smaller horsepower motor and probably save a lot of money. Well, you cannot base that purely on the efficiency as recorded during the running load of the motor. A motor running at 70% is probably not optimized for sure, but the peak efficiency of motors is commonly around 80–85%. Okay, and there's quite a big range actually. They'll say anywhere from about 70 to 85% is usually optimal efficiency. Too often we're thinking, hey, if that motor's not running at 100% load, it's not running as designed. And that's the biggest misconception of energy efficiency motors today, and one that's, I think it's just important to understand that. Other things you hear, okay, a more efficient motor is going to have a higher power factor. Not necessarily. Okay, that's a completely, there's more variables than the air gap that create the power factor value, and so it's definitely not directly linked only to energy efficiency. More efficient motors run cooler. Well, that's certainly not the case. One of the things that I've seen over the years, being involved in testing motors for so long, is that back in the good old days, we used to be able to put our hand on the motor, and if we could leave it there for 10 seconds, we were okay. The motor's not overheated. Now, the motors have changed dramatically, and that probably establishes my age a little bit. But today, many motors that you walk up to, if you were to place your hand on that motor, you're going to be pulling back a burnt finger. It is very hot. The heat is quickly and rapidly removed to the outer skin of the motor, and as a result, the motors run hotter today. Excuse me, I'm clearing my throat just a little bit. Now, finally, an energy efficient motor develops less torque and may not accelerate load. Again, the design criteria involved in torque and acceleration are not geared or geared around or completely dependent on energy efficiency. So these are the misconceptions that are spoken of, and we need to make sure and get past that. Now, let's talk about energy cost analysis. Here you got a company who's under pressure to perform or go home. And what do they need? In terms of energy cost analysis, if you've got people looking at, hey, we've got to get efficient, what are the things that they need help with? Number one, assistance in repair or replacement. Now, what are we talking about there? If I'm looking up here at this top left corner, okay, I'm thinking, okay, replacement is our primary goal, right? We want to get rid of the old and replace it with new higher efficiency motors. Well, hopefully we've spelled out a few reasons why that may be a big misconception, okay? I think it's important to understand the cost of doing that. And we're going to spell that out pretty clearly through this presentation about the difference of the misleading cost sometimes with just pure replacement. The big help that needs to be had is, should I replace or repair? And I think that's a big decision to make, and certainly energy efficiency is a factor and should be involved in that. The second thing on the upper right provides estimated cost savings for replacement of an existing motor with a higher efficient motor. Okay, it's important to know what the cost of that's going to be. This all comes down to return on investment, right? If the motor cost is a specific amount, how much are we going to save in electric power, and how quickly can we get our money back? Okay. The third thing, determine simple payback time and annual savings. And this becomes critical, especially when you're talking to the bean counters. How quickly is that new motor going to return my money? And that's the big debate. Okay, which leads us to the fourth thing, provide a detailed report to support final decisions. We're going to go over these four things. We're going to talk about what it takes to make that final decision and whether a return on investment does exist, because the whole goal, as you can see in the middle there, is let's be green wise, not green washed, and we're going to show you what we mean by that. Let's take some numbers as an example here. Okay, from these numbers, you can look at, from nameplate to nameplate comparison, we're looking at about a $60,000 annual savings. Okay, now the numbers that you can see here are pretty high. These are kilowatts per year usage. A lot of things that we're going to take into account in terms of what it costs to replace. In this example, we're looking at about a $75,000 repair of the existing motor versus about a $150,000 replacement of the existing motor. However, when you go down through, looking at just simply nameplate of the new motor versus nameplate of the old motor, and you look at the power used and the energy saved, okay, at the bottom we end up, it ends up being a $63,000 investment, but with the annual savings of $60,000 a year, okay, over here on the bottom right-hand side here, you can see that that's about a 1-year payback. Well, now, if you go to the accountant with that, a 1-year payback's pretty easily authorized in it. And then, of course, it's going to be an interesting question to ask your own facility. What is our general payback expectancy for business decisions made to the good of the company? Is it 1 year? Is it 2 years? Is it 5 years? But the important point of this number is a 1-year payback as a result of $60,000 saved in electrical power costs is a nameplate-to-nameplate comparison. It's not taking any real-world environment numbers on the motor itself. So as we advance forward, let's look at now that same situation, but instead of just taking nameplate versus nameplate, now we're looking at actual measured values of the existing asset. Now this is where it becomes such a critical when it comes to energy cost analysis. Knowing information on the existing asset becomes critical. Because when we actually build known information off the running asset into this same exact algorithm, the $60,000 a year drops to $10,000 a year. And $10,000 a year is a big difference when it comes to return on investment. So now you go back to your accountant and you say, hey, our payback for this project for buying this brand new high efficiency motor is about 5.81 years. Well, 5.81 years is received very differently by your accountant. Okay, and probably will be rejected, in fact. Most companies that we talk to have about a 1 to 2 year payback. Anything more than that really goes into consideration and is often rejected. In fact, if you look at down at the bottom right here, the capital recovery, if you start building in interest rates and stuff, ends up being a 7-year return, and that becomes just, unacceptable for most accountants. So green wise is a real deal. Okay, now let's look at this company, Austin Energy. They looked at this. They looked at the actual cost to replace, the cost to rebuild, and the cost to recondition. Now, replace is straight out replacing the motor with a high-efficiency motor. Okay, and a specific Decker power plant. This is one you can look up. You can look it up online and verify it's a real power plant. The replacement costs were way up around $300,000. Okay, which is a significant amount of money. Okay, for the motors that they identified that weren't, or really the systems that they identified that were running inefficiently. Now, when you talk about rebuild, okay, rebuild is taking these motors and just instead of actually replacing them, let's rewind them, clean them up, and make them, make them at least smell and look good. Okay, not a bad plan. Okay, but again, not necessarily the best or most green direction that someone could take. So in terms of rebuilding, you can see that now we're dropping down around $100,000. Okay, so there was a significant difference. We rebuild the motors, $100,000 investment. If we replace the motors outright, approaching a $300,000 investment. But let's look at the third one, and of course I conveniently colored that green. And this comes to, what this really brings into play is, in looking at those systems and those motors that really were operating in an inefficient or an unreliable state, and that was the whole thing, is could we apply a reliability approach to these motors and actually recondition them? Those that needed to be rewind them, but those that needed to be reconditioned, let's just clean them up. Let's align them. Let's remove the power circuit anomalies. Let's verify that inductively these things are balanced. Let's verify the insulation integrity is good. Because every time one of these motors are failing, okay, not only is there waste product, there's wasted energy, and there's wasted resources. So the whole idea between approaching reconditioning versus rebuilding versus replacing is to apply all the technologies and reliability, and they were able to draw the price down underneath $50,000, and that's huge. So this is just their numbers and their comparison as to what it was going to cost them to replace versus rebuild or recondition. At another sandhill plant, you can see the numbers were even higher. Okay. Now, it's hard to argue with these numbers. Now, what's interesting is, are the reconditioning numbers, after they recondition or rebuild these motors, are they going to overall truly be drawing less power? And that's something that they're on a continuous mode of evaluating and continuing to feedback information on that to make sure that they're doing the right thing. But hard to say that saving, $500,000 in just pure replacement costs with the possibility of a 5-year return on investment on some of those assets was the right call. Now, one thing I want to make sure and spell out, from the PDMA perspective and from the reliability perspective, UE, PDMA, whoever, going green in terms of, reducing the power demand to manufacture processes, whether you're manufacturing electricity, like this company is doing, or whether you're manufacturing cars or rockets or fuel or whatever you're doing. There's certainly the largest percentage of power or cost, the largest percentage of cost to any facility when they're in terms of the purchasing of an electric motor is the power. No matter how expensive the motor is, the power becomes the largest lifetime expense of ownership. That being said, we cannot dismiss, and we don't want to dismiss, the importance of an occasional replacement of a motor due to a very poor efficiency performance. Okay, and neither is Austin Energy. They're not dismissing the possibility that, hey, if they're running a motor that's operating at 70% efficiency, it's 40 years old, the reliability is in question anyway. Rather than rebuild that motor, I might consider dropping $100,000 on a replacement and getting some return very rapidly. On motors that are drawing that much power with that much of an efficiency difference, that's huge. That wasn't the case in these situations. With Austin Energy, the biggest issue they had was motors failing in the middle of the night. And so that was a major cost for them to do business, and it required a lot more power to deliver power than it would by operating in a reliable state. So I think what we're coming to the conclusion here is reliability first, okay, not necessarily just energy efficiency, not that it's a bad thing. In speaking of reliability first, there are three major areas that we all need to focus on. Those areas start with quality control. Now, in this situation, you got this guy here that's testing a motor, and he's testing a motor before it ever gets installed. In fact, he's probably testing it off the back of the truck before it goes to the warehouse, okay? There's a variety of situations you might find yourself in terms of quality control of electric motors, but we cannot overlook the impact of making sure that you get what you pay for, okay? It certainly is not a good thing to install a motor that the first time you push the start button, that the thing blows up or it smokes or whatever you want to say. Now, that being said, quality control becomes very important. It's a nice feeling to know when I take this motor off the warehouse and I install it into the system that I don't have to let the new guy start the motor, which is always a second option. If you don't know the reliability of the motor that you're getting ready to start, then let somebody else start the motor. But that's not always the good choice. Quality control is huge, and motor repair shops, motor manufacturers, they put as much as they can into quality control. It's the technicians on site, it's the site managers, the site supervisors that have to take the next step and make sure they're getting what they paid for. The next step, not always the most exciting, is the trending. Okay, everyone, trending is you've heard the phrase, trend is our friend. And although it's the most time-consuming, you got to go out and take the data. Somebody's got to take the data, right? But in terms of that, the value of that information when it comes to seeing the onset of a reliability reduction or seeing the presence of an anomaly that needs to be taken care of now to extend the life of the motor to the desired 15 or 20 years. Trending is big. Quality control is a good start. Trending is the next most critical part of that trio. And speaking of the trio, the final is troubleshooting. No matter how much quality control effort you put into the motor, no matter how much trending you do to identify conditions that are conducive to failure, eventually there will be troubleshooting. Now, it may not be the fault of the motor, but it will happen. And when that happens, you want to be efficient. You want to be efficient at identifying what the trouble is and getting to the next step so that motor can be turned on and become more productive. So, in terms of reliability first, those three areas are critical, and we need to be paying as much attention to each one in its own element. Well, when it comes to electric motors, there's a variety of failures. We've all experienced them, and the question we like to ask is, where do you experience failures? Now, this study that you're looking at here was one done, not the newest study, I believe it was 1980, mid-80s, 85 actually, as it's listed, by the Electric Power Research Institute. GE was actually the contractor that performed the study, and there was over 6,000 motors involved in this study. Now, that's not a small number. So certainly you can look at that number and you can say, hey, this is a pretty significant deal. A lot of motors taken into account for this study, and the number one failure mechanism for electric motors was, as you can see, bearings at 41%. That's probably not going to change anytime soon unless they come up with some new metal for bearings, alloys, or something like that to extend the life of bearings. But they put every effort they can. Doug and the guys at UE are instrumental in trying to minimize that failure. using ultrasonics, but it's always a failure mechanism that needs to be paid attention to. The stuff we like to focus on at PDMA is the other half of that, which is the 37% stator and the 10% rotor. Combined, we're looking at almost 50% of the motor failure, mechanisms are electrically related and need to have that some focal attention on that. Now, your numbers at your facility are going to change slightly. Okay, this is, like I said, all the motors involved in this study were utility related. Many of them were 4,000 to 6,900 volts, and so it's something to take into account as you're looking at your own failure mechanisms and what they mean to you and what technologies you need to have on board to move forward. Well, what are the fault zones that we look at? What's going to take your motor to an unreliable state? A lot of people look at a motor as a piece of metal that goes roundy-roundy and makes our systems work, right? Well, that's one way of looking at it. We like to break it down a little bit further. We like to break it down to maybe 6 different fault zones to allow you to more easily evaluate, what needs to be looked at for the motor. Number 1, power quality. Power quality is what is fed to the motor. Many of you have heard a phrase from your mom when you were growing up, which is basically you are what you eat. Well, to some extent, a motor is as reliable as what the power is sent to it. So if you feed it bad power, you can expect the motor to perform badly. Power quality is essential, and it's something that we cannot overlook. You'd hate to install very high-quality motors into a situation only to have the power quality reduce the reliability of that motor. Second fault zone, power circuit. You could have good, clean power, but if it's traveling through circuits that are unhealthy, as seen in the picture here, then the power being delivered to the motor is not going to be balanced and it's not going to work well. Changing my color scheme there for just a second. The third area of interest after power circuit is the stator windings. Okay, once power enters the motor, okay, the stator windings take that power and they deliver rotational magnetic fields to turn the motor round and round. Well, those stator windings are essential to you want high quality up front. You want to verify that you're getting what you paid for, and then monitor to make sure there's no imbalances that occur during the normal operation of the motor. From the stator, we go to the insulation. Now when we refer to insulation, we're talking about the ground wall insulation. That insulation which prevents the power that we're trying to save from going from the windings to ground. Okay, when that happens, usually there's smoke involved and a stator rewind. And so that insulation quality has to be good. The fifth fault zone is the air gap, which is the space between the stator and the rotating element or the rotor of the motor. Now, that should be a nice, even air gap all the way around, and sometimes that does not happen. And as a result, you can create electrical noise, you can create vibration, bearing failures. You can create a lot of things from that air gap anomaly. Worst case, a rotor stator rub. Which brings us to the sixth and final fault zone, which is the rotor. Now, the rotor is the rotating element. It's the one that's most tangible. We see it turning. We know it's down there. For an AC induction rotor like we see here, the power is induced onto it, and anything going wrong with the cage or the conductive elements of that rotor can create a problem. Again, bearing failures, stator winding failures, lamination damages, whatever. There's a variety of things that can go wrong, but that just gives you kind of an idea that let's don't think of a motor as a piece of metal that goes roundy, but yet there are independent, individual components within the motor that we want to focus on and try to get beyond. Which brings us to our last subject, which is cradle-to-grave reliability. Now, excuse me, cradle-to-grave reliability, again, you've heard the phrase before, but how does it apply to your motors? And it's an interesting subject, and I've been through a few presentations where they talked about different elements of the reliability effort, and I like to put it all together and kind of say, hey, let's follow the life of a motor. What should it experience as it comes to your facility, or even before? And let's start with the very top, design. You see this gentleman in the picture, and he's looking at a schematic. So let's imagine that he's building on another leg of the plant. And the question I like to ask everybody in the audience is, have you ever been involved in the new project design level of plant expansion? And if not, as a maintenance personnel, then that's probably an oversight by the facility. Now, by oversight, I mean as a maintenance personnel, the maintenance department really should be involved to some extent in discussing this expansion. Let's take motors as an example. I like to bring up the example where we had the phone call came into our technical support asking us if we could help them make a decision on whether or not a motor needed to be rewound. And it was not a huge motor. I think it was probably, maybe a 100 horsepower motor, but it was deep within a facility to the point where a helicopter was required to get that motor out. Now, the thing you have to ask yourself is, if we were at that facility back when they were first designing the building and designing the systems, would we have mentioned the possibility that how do we replace that motor in the event that it starts to fail? And would they have gone through with the construction had they known it was going to require a helicopter? And I'm guessing the answer is no. So at the design level, this is where we start. And so as you guys are at your facility and you hear expansion projects, let's make sure a maintenance personnel is involved in those committees and those conversations about the expansion, because it's going to be you guys that make the difference in terms of whether or not the assets that we need to monitor as maintenance technicians, are they going to be in a situation to optimize the analysis and to optimize any repair necessary? Well, the next step is buying the motors. I like to ask, when is the last time someone from your facility visited the motor repair shop when buying or repairing a motor? And many times, and unfortunately all too often, I hear, well, we don't go there very often at all. Well, that's a big problem. That's something that, even myself, I've been involved in the industry for many, many years, and every time I step foot into a motor repair shop, I learn something new. Every time I step foot into a manufacturing facility, I learn something new. That being said, I think it's important to to make sure that you're involved with that. So visit your repair facility. Get to know those guys. Make sure that your quality control standards are being utilized. And this is something that's very popular today, getting your motor repair shops audited by someone to verify that your procedures and your processes are in fact being met. Okay, next in line, storage. I remember walking through an aluminum facility doing just a review of their reliability programs, and I'm looking over at this area on the lower floor of the building, and they had a bunch of old motors that were just thrown over to the side, stacked up on each other. Just I figured, okay, it was just a dumping ground for old motors. So I asked the person, why do they keep their junk motors? And he looked at me kind of strange, and he said, well, that's our spares. And I said, oh, well, we probably ought to talk about that, right? The picture I'm showing here, not a new picture, it kind of has that old feel to it, but it's a large motor storage facility. You can see things are lined up nicely. Let's hope it's an air conditioning environment, but there's a variety of things that need to be taken into account when storing motors. Are they setting on platform? Are they setting on concrete that could have a vibration? Can the concrete, can there be moisture in the environment? Is it an air conditioning controlled environment? All these things. A lot of times you walk into high quality storage and you see plastic wraps. They're rotating the motors on a regular basis, and all this to prevent burnelling of the bearings, to prevent the seepage of moisture in and out of the motor. Just a variety of things that need to be taken into account. Storage is important. You want to be able to take a motor out of the warehouse, install it, give it a quick test, and make sure that you're getting what you paid for. Which leads us to the next step, installation and startup. Here you can see technicians on site for a brand new motor installation. And before they turn this motor over and say, okay, we're good to go, they're doing the full installation and startup testing. Now, I can't say enough about this. Much like ourselves, when a brand new baby is born, if they get started healthy, it usually means a more healthy childhood, doesn't it? And well, it's the same with a motor. If the motor starts off on a bad leg, maybe not the motor's fault. It could be a bad power issue, power quality issue, a power circuit anomaly, a voltage imbalance due to a bad transformer tap, whatever it is. If you can identify those conditions quickly, it prevents any type of reduced reliability right off the get-go. And so a good startup is important, and I can't say enough about that. Every new motor getting started up should have a full diagnosis made to make sure that power quality, power circuit, insulation, everything on that motor is at par and as it should be for a brand new motor. Think of the first house you ever bought. If it was a brand new constructed house, you wanted everything to be perfect. You wouldn't accept anything less. But no reason, the same thing should go for a motor. I want a perfect power quality. I want perfect power circuit. I want everything lined up before, I turn this motor over and say it's going to give me 15 years of operation or more. So installation startup, can't say enough about. That brings us to operate. Okay, someone has to operate the motor. And And the reason I focus on this is because there are sometimes in operations and maintenance, how would you say it, not always do they get along that well, right? And so in terms of operations, I'm gonna implore that you guys as maintenance specialists, as maintenance personnel, to give operations a chance to be involved in the reliability effort of your motor. Now I say that, and what I mean by that is that a lot of times the person who pushes the start button and watches the meter go up and down and stabilizes may know nothing about the motor. However, he gets to see it start up every time, doesn't he? So he knows something about it. I use my wife as an example a lot of times in this situation. Our family vehicle, she's in it a lot. We've got 4 kids. We're running to every type of sport known to mankind. And so she's in that vehicle a lot and hears and feels things that I never do. Okay? So when she comes to me and says, hey, there's something wrong with the engine, it used to be I would question that. I would get myself in the van, I would drive it around the block, and I would give my own assessment. Well, how valuable is my own assessment when I'm never in the vehicle? Well, every time I would be wrong if I would disagree with her. So at this point, if she says there's something wrong, we just take it to the shop. They always find it, they always fix it, and she's always right. Now, take your operator, for instance, may not know anything about what the motor's doing, and may not know how it works, but he sees it start, he sees it run, and trust me, he does know he does know valuable information that he can give you to help you get to the bottom line in a troubleshooting situation. So give operations a chance. Finally, maintain. Okay, you designed in good reliability, you bought the right motor, you stored it properly, you installed it, and you verified the startup. You're working with the operations department to make sure it's run properly and any indications that might indicate a reduced reliability. And now we just have to maintain it. Okay, an occasional review of the power circuit, the power quality, the stator, rotor, air gap. Occasional review of this is going to make sure that you're going to get the expected 15 to 20 years life out of a motor or longer. And as critical as that, and given the whole green element of this presentation, verify that the efficiency of the motor is optimized, is running where it should be, and that we're not using more power than required or than that we should or need to perform to deliver or to develop the product that we're trying to deliver. In conclusion, the 3 areas that we talked about today, and we want to make sure and review here as well. Build a motor reliability program first. As important as energy efficiency is, and I hope that I've pointed out that it is an important element, that energy efficiency can save you, hundreds of thousands of dollars in certain situations, but too often it's not nearly as fast as you might think. But so a reliability program first. If you focus on reliability first, it's your biggest return on investment. It's going to reduce your power consumption more rapidly than just a simple motor replacement. And the cost, I mean, if you think about the impact on the environment, it's, building new motors and buying them all requires natural assets and natural, environmental, it does have an impact on the environment. And so buying new motors only to improve efficiency by 0.1%, and in certain situations actually reducing efficiency if you don't know what you're putting the motor into, is not doing your company any good, it's not doing the environment any good. So reliability is always the first best bet. Second, apply the fault zone analysis principles. We talked about the power quality, power circuit, insulation, rotor, stator, and air gap, those 6 fault zones, okay? If you take care of those 6 fault zones, your motor should give you expected life. Don't just look at a motor as a one element, how's the motor? Well, it looks good. Make sure you ask the question, well, what about the individual fault zones? How are they looking? And finally, monitor your motor assets from cradle to grave, okay? Don't just stop at don't just start once the motor's installed and already starting to give you a hiccup, right? You want to start from the very beginning. Try to get a good installation and startup on every new motor installed, even if it's just from repair, okay? Try to get a baseline on every motor coming into your facility. These are critical elements in the overall reliability effort. And finally, be green wise, not green wash. Know that when you're ready to replace a motor, don't just look at nameplate versus nameplate. Okay, nameplate versus nameplate is going to be misleading. It's going to tell you, wow, we're going to save hundreds of thousands of dollars in the first year. And when your accountant comes back to you a year later asking, hey, where's all that savings? Then you got to answer that very hard question. Which brings us to questions. So I hope, Doug, you're out there and fielding all the questions that are coming in. But From this standpoint, if there's any questions that you have, certainly I think there's ways to get those questions to Doug. I think that that he could probably present those questions to me and we can get them answered. Certainly in terms of the access to PDMA Corporation, 813-621-6463 is our number. Please visit our website for more information on energy efficiency or motor reliability, www.pdma.com.
Thanks, Noah. I think we'll actually field a couple of live questions. So for those of you in the audience that have a question, go ahead and click on the hand on your screen there, and we should be able to see who it is that's asking the question. We'll unmute you and let you ask Noah directly that question. So if anybody has any questions right now, certainly there's an icon for a hand, and you have to have a mic, or you have to have called in to be able to ask a question. If you're not comfortable asking the question live, that's fine. But we'll go ahead and, okay. We do have a question here, Noah.
Okay.
From, I'm struggling with the name, from Adnan Algila.
Okay.
We've unmuted you. Go ahead and ask the question, sir. Yeah, looks like we're having a little trouble with that, little technical difficulty there. But certainly you can post your question online, or if you want to give out your email address, Noah, people could email you directly with any questions about the presentation.
Sure, that's easy. My email address is noah@pdma.com, and that's NOAH@pdma.com, and that'll come directly to me. And so I should be able to field any questions, whether it involves different levels of motor reliability or energy efficiency.
All right, great. I do have another question coming in here, Noah, and we'll go ahead and unmute Yulia Gadsden. Yulia, are you able to ask the question? Well, apparently the live question asking isn't working so well, Noah.
I think a lot of people, like myself, even if they don't have microphones built into the actual, built into the actual computer, a lot of times they don't realize that until they're ready to ask the question. But hopefully that's not the case.
Yeah, we'll get some people to send in some emails, and certainly if you have questions regarding the webinar itself, feel free to email Noah. He gave out his email address, or you could certainly email us and we'll get the question directly to Noah. My email is dougw@uesystems.com, or you're welcome to email info@uesystems.com. So thank you, Noah. That was a great presentation. Certainly appreciate your time this afternoon. Some valuable information there. Just sort of to wrap up, you can certainly visit uesystems.com for some other ultrasound opportunities on leak detection, steam trap and valve inspection, electrical inspection, bearing inspection. Got all kinds of training courses that are available. And look for some future webinars. We're going to be putting on just about one a month. We'll see as we get through the holiday season starting next month, November, December. But we're planning on doing one sometime in November. So look for an email to come out from UE Systems on the next topic that we'll do. So actually, if you need to contact us, again, that email address is info@uesystems.com, or you're welcome to email Noah directly. Thanks, everybody. Have a great, safe, and reliable day. Noah, certainly appreciate your time. Take care.
My pleasure. Thanks, Doug.